morning students. Today we will discuss about Ohm's law. Ohm was a German scientist or German physicist whose actual name is George Simon Ohm. He was doing an experiment in his lab and he wanted to find the relation between voltage and ampere, or he wanted to find the relation between voltage and current. We first take a metallic wire and connect in an electric supply. To find the relation, he want to study the amount of current when different amount of voltage is passed. So first what he did, then he first connect an ammeter in the wire and also a voltmeter to get the reading of voltage and current. So he connect the ammeter in series and voltmeter in parallel. Understand? Suppose he take a 1 volt battery first and find the reading of current in the ammeter. So he first tabulated both voltage and current inside the wire. First he take 1 volt, he get the reading. Suppose he get the reading that is 2 ampere. When he take another battery of 1 volt, then he gets, that means here is 2 volt, he get that is it is approximately 4 ampere. Similarly, when he connect another battery of 1 volt, that means it is 3 volt, he get that it is the 6 ampere current passing through the ammeter, and it is 6 ampere. So now he try to find the relation between this voltage and ampere or voltage and current. He get that is V by I is always constant. That is here V by I, if you take V by I, that is 1 by 2. Similarly, if you take V, suppose it is V1 by I1. Now it is V2 by I2. So V2 by I2 equal to, he get 2 by 4 equal to also 1 by 2. Similarly, V3 by I3 equal to, he also get 3 by 6, also 1 by 2. That means he get the relation that always V1 by I1 or V2 by I2 or V3 by I3 equal to 1 by 2. That means always V by I remain constant. To this constant he name it as resistance. And what is resistance? Resistance is the blockage of current flow through a metallic conductor. That means if you connect a metallic conductor to any electric supply, always the resistance remains same, means opposing of the current flow is always remains same inside a metallic wire. But it is always constant. How it differ? When the temperature increases, then the resistance increases. That means suppose how temperature vary the resistance. When temperature increases, the particles inside the wire vibrate. So when electron pass through it, electron become trapped, or it is difficult to pass the electron inside the vibrating metal. So when temperature increases, resistance decreases. That means here to the resistance, temperature is a factor. So we have to take the temperature constant so that the resistance always remain constant. That means suppose first I will take 1 volt battery and I will get 2 ampere current. Here suppose it is 25 degree Celsius. Suppose when I apply 2 volt battery or 2 volt voltage, then 4 ampere we will get. That time when I will keep it 25 degrees Celsius, otherwise I cannot get the 4 ampere current, it may, suppose if the voltage will increase, it will increase the temperature amount, because particle will vibrate more and more and it will increase the temperature. So we have to reduce the temperature so as to get 4 ampere current. That means when temperature remain constant, so that we will get the same amount of the same multiple of the current. Similarly, here we have to keep it 25 degree Celsius, so that we can get 6 ampere current when we apply 3 volt of battery. And as this is the one type of metal wire, always the resistance remain same. Suppose I will replace the wire. Suppose here is the copper wire and I will replace it with iron, then iron will give another type of resistance. Understand? Because nature of substance, that means resistance also always remain constant with the nature of the material. So if I change the material, then I cannot get the same amount of resistance. Similarly, length of the resistance, length of the wire. Suppose I will take 5 meter wire, then I will get one amount of resistance. Suppose I will take it 5 kilometer, will I get the same amount? No, I cannot get the same amount. That means current will feel it is difficult to travel large distance. It is easy to travel 5 meter distance. That means as it is difficult to transfer, that means it is here is resistance force is more. So if the length of the wire increases, resistance increases. That means suppose you will travel just from your school to the gate, it is easy by foot. Suppose you will travel to Puri, that means it is difficult, it will difficult to you to travel more. Similarly, to travel the current or to travel the charge, it is difficult to travel more distance. So here is resistance is more if I take the length of the wire large. Similarly, area of cross section. How? Suppose the road is a single way road. Suppose single way road, or suppose the road is of 5 meter wide. It is if the government will increase, or if the government will increase the diameter, suppose it is 10 meter, which one will easy to travel? In which road you feel better to travel? It is the 10 meter wide road. Similarly, if the wide of the wire, or the thickness of the wire, you can say, or area of cross section of the wire, if it is more, then it is easy to travel the current. That means here is less resistance. That means if the cross section of the wire is more, the resistance is less. If the cross section of the wire is less, then resistance is more. That means it is inversely proportional to the cross section, or area of cross section, inversely proportional to the area of cross section. But length to the length, it is directly proportional. That means large length, so large difficulty. That means resistance is one type of difficulty, you can say. That means it is directly proportional to the length, but inversely proportional to the area of cross section. Similarly, nature of material, you know, temperature, it is directly proportional, because if the vibration will increase, it is difficult to travel the electrons or charge. So it is directly proportional to the temperature. Similarly, a number of factors are there on which resistance depend, but you cannot, generally we are saying that here is resistance is constant, but we are maintaining it constant by maintaining these factors. Understand? That means Ohm had maintained these factors constant, so that he get the constant value of resistance. That means the material which Ohm had taken, that was the same material. The temperature he had maintained constant. The length of the material was the same, and the area of cross section also was the same, so that he get the same amount of resistance. Understand? Now, what is the unit of ohm? Unit of that is resistance. We know that the formula for resistance is V by I. Here is R equal to constant. That means V by I equal to R. Understand? So V by I. Then V is volt and I is ampere. So it is taken as ohm. To respect the scientist, the unit is taken as ohm. Ohm is written like this. So volt by ampere is ohm. We can get another unit also. How? We know that V equal to W by Q whole divided by I equal to Q by T. So this is our implies we can get W by Q into T by Q equal to R. We can get W equal to joule, Q equal to coulomb, into T equal to second, Q equal to again coulomb, equal to R equal to ohm. Implies it is joule into second into coulomb minus 2 equal to ohm. In other way, we can write this also as ohm. Ohm equal to joule into second into coulomb minus 2. Then how will you get the graph? By plotting this voltage and ampere or voltage and current in a graph. What will you get? Suppose this is the graph of voltage and current. Suppose this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. What will you first? It is 1 volt, 2 ampere. That means at 1 volt it is 2 ampere. This is the plot. Then at 2 volt it is 4 ampere. Suppose it is 2 volt, it is 4 ampere. Similarly, at 3 volt it is 6 ampere. So what will be the, how will be the graph? Graph will be the slope or straight line. You can say it is the slope or straight line of the VI graph or VI graph. It is the slope. That is the which one? This is the resistance. Resistance is the slope. Why I am saying the slope? Because the formula is V by I. R equal to V by I. That means you know that y by x equal to the slope y by x in graph. If y by x will take, this is the slope. So slope equal to y is V here and this is the x is I here. Slope, this is the slope V, as it is the VI. In the class 9 you have studied how to get the slope and how to get the area. Understand? Area equal to multiply, slope equal to division. So resistance is the slope between the VI curve. Suppose here is the graph. Suppose like this. Suppose here is V, here is I. There are two graphs. Suppose which graph has more, this is also resistance. So this is R1, this is R2. Which is greater? How will you get R1 or R2? Pause the video and try to solve this one. Now the answer is R1 is greater than R2. How? Suppose I will take R1 is suppose we know that V by I formula is V by I. Here look at this. Suppose here is at, suppose it is the 2, it is 4, it is 2, it is 4. Suppose at this point, and here is at this point, same. I will take same height at this point. Here is the it is almost, it is suppose 2.8. That means at first case, at R1 case, it is at almost 2.8, or V is 2.8 by I is almost, it is 2.2. Suppose in R2, here is R2 means 2.2 is high, but it is almost 0.8 by 2.2. Which one is greater? Clearly R1 is greater than R2. That means in the graph which will show V in y-axis and I in the x-axis, if there is two lines, then the line which is in the upper section, this is the this has the more value of resistance. Similarly, let's do another example. Suppose here is the graph. Here is I. Suppose alter. It is I. It is V. Which one is greater? Here clearly R2 is greater than R1 because it is alter. That means suppose I will take, here is 2, is 4, here is 2, here is 4. At any point you will take. Suppose this point, at this point you will take. Here is, suppose I will get R1 equal to 4 by 2.2, but R2 if you will get, it is alter. That means it is 2.2 by 4. Here is 2.2 by 0.8. Which one is greater? Clearly R2 is greater. This much is our today's topic. So thanks for listening.